All right, gang, today we are going to talk a little bit more about disc brakes, and specifically, we're going to talk about brake maintenance. Now, I know I'm just looking over here, I've got a few notes on the computer, so you're going to have to deal with that. So, first thing I want to talk about as far as the brakes go, I want to talk about preliminary brake inspections. Of course, anytime you go to diagnose something on a vehicle, it is best to get a customer description of exactly what the concern might be. Now, when you're diagnosing brakes, if you can take the vehicle for a drive safely in order to diagnose a noise, a rattle, a squeak, or a grind, it is a good idea to do so. But there's a few things that you want to do with the vehicle before you just jump behind the wheel and take that sucker out on the road. You want to make sure it can stop. So, fire the car up, and the first thing you should do is look for a red brake warning light. Now, if the park brake's on, that could be the reason. Try the brake pedal before you disengage the park brake. If it holds pressure, disengage the park brake and make sure that red brake warning light is off. If that red brake warning light is off and you've got good pedal, you can proceed slowly across the parking lot. Try applying the brakes at this point. If it makes a god-awful grind, stop. You do not want to take that vehicle out on the road. If it makes a little squeak, you're probably all right. Once you've got that vehicle test driven and you've made sure it doesn't shake or groan or moan or any other terrible thing, what you're going to want to do with that vehicle is bring it into your service bay. Now, once that vehicle's in your service bay, go ahead and lift it up on the hoist. Of course, we're going to give each and every wheel a shake to make sure that we don't have a bearing or a front end concern, and that's fine. But once we've got it up in the air and we're doing a brake inspection, what you want to do is remove every tire on the vehicle, excluding the spare, of course. We need in to see all of the brakes. I cannot tell you how many times I've seen people burned by only inspecting one side of the vehicle. Don't be that person. Next, we're going to have a quick inspection of flex hoses, the face of the rotor, things that you can see without taking anything apart. Make sure all the fasteners are there and they're done up snugly before you start taking things apart. Now, once you've had a quick visual inspection, don't trust the inspection holes of the calipers. Actually take the calipers off of the brackets or off of the vehicle so you can get a good look at the pads. You want to hold them in your hand and inspect them fully. When you're looking at the pads, you'll of course again have them in your hand, and we're looking for any cracks in the surface of the pad. We're looking for any uneven wear. If they got bound up or if the caliper was flexing, they may be lower on one side than they are on the other. That's not acceptable. We also want to make sure that they're the right pad for the application. When they sit on the rotor, they should cover the rotor without falling off the edges of it. Once you know that the pad is good as far as the construction goes, you want to make sure the pad block isn't falling off the backing plate, that you can't get your fingers or air in behind it. Any separation, any cracking, any terrible heat glazing, deep grooves, go ahead and replace those pads, of course, with the customer's authorization. Once you've got the pad off and you've determined that there's no huge visible fault with it, you're going to want to grab a pad gauge like this or another measuring device. Now, this one is an old school one from General Motors from years and years ago, but you can buy these off of any tool truck that there is now. The things that you need to remember: if it's 3 mil or less, this is 3 millimeters and that is 2 millimeters, that pad should be replaced. If it is 7 millimeters or less, that pad should be inspected, make sure it's okay, but it can be put back in service. If you start getting around this 4 millimeter size, let the customer know, hey, it's probably not worth servicing up your brakes. Next time you're in, we're probably going to be into that 3 mil replacement interval. Just let them know that the end is nigh. If it's 5 or 6 millimeters, that pad's still all right. I know the tool says proceed with caution, but you should be just fine. Anything above 7 mil is almost a new pad. Depending on the manufacturer of the pad, we could be anywhere between 8 and 12 millimeters brand new. These pads that I just took out of the box, we can see that they are almost exactly 12 millimeters. We'll try out this other one. That's the 10. We can see that they're a little bit taller than 10, so that's probably 11 millimeters of new thickness on that pad. If you take these out, there is a routine maintenance to do on pads and caliper brackets. What we want to do if we're doing the maintenance on these pads, if they are good to be put back in service, we just have to clean them up. We want to make sure that these pads can move freely back and forth inside the caliper bracket. So we knock these out of the caliper bracket and we scuff up or take the corrosion off the tips of the pad, here and here. We do the same on the caliper bracket. We make sure the caliper bracket's nice and clean and we clean up all of the pad shims. These are pad shims here. We then apply these back into the caliper bracket and apply just a little bit of lubricant on the tips of the pads. We don't want any lubricant on the friction surface. Obviously, greasing up something that we want to slow us down is a terrible idea. So we grease these up nice and fresh and we reinstall them into their homes, making sure that they slide freely. They shouldn't have a ton of play in them. If they have too much play, you're going to get rattles or knocks when the brakes are applied and released, and that's that pad moving back and forth in the bracket. Again, not an ideal situation to be in. So maintenance is pretty simple as far as that goes. If they have any slots inside of the pad, what you should try and do is knock the collected dust out of these slots. I find probably the best thing for opening these slots back up is a saw blade, believe it or not. If you have a hacksaw, it works very well. You mount the pad in a vise, drive the hacksaw blade back and forth. It'll knock out the brake dust, and then this brake will be ready to be put back into service. If you're addressing a noise concern, maybe a little chamfer just on the edges, and make sure the front and the trailing edge and the leading edge are both properly chamfered as well. That's about it for pad maintenance, not a big deal. The bracket and the caliper itself. If we're looking at the bracket and caliper itself, I got a caliper on the floor. We want to make sure that the piston and the caliper can go back. Usually you would use a threaded C-clamp or a piston turn back tool. I happen to have my vice grips on me. These are not the right tool, don't use them. But if we put our vice grips in the caliper, we should be able to knock that piston backwards. In this case, this piston is seized. It doesn't move backwards at all. Caliper seized. It's garbage. This should push back fairly easily. If you are replacing the friction material at that time, go ahead and crack open the bleeder screw and allow the fluid to escape the back side. This one, obviously, the bleeder screw is not an obstacle here. We don't have a flex hose on it. The reason that we open up that bleeder screw is we want the old fluid out of the caliper so we can add fresh fluid in at the master cylinder. Since we're doing friction material at that point, it's a good idea. If you're not changing the friction material and you're not doing a brake flush, you should be able to easily push that piston back into the caliper housing, and that fluid should return to the master cylinder. That's why we don't overfill the master cylinder. So while we're servicing the caliper, we don't want to put any glue or adhesive on either side of the piston or the fingers. A caliper, when it sits up against a pad, has an anti-rattle clip on the pad. That should be sufficient to quell the noise or any noises that may be apparent from it, unless otherwise directed from the manufacturer. When we've got this caliper, we're going to take out the bushings from the caliper. I've got this other caliper over here. There we are. Bushings come out nice and easy, like so. Inspect the O-rings or the rubber bushings inside of it. Make sure they're still in good nick. This one is quite damaged. That should have new rubber seals put into it. At that point, I would recommend new O-rings for the caliper slides. Upsell the customer on something like that. I would take this over to a wire wheel and just blow the corrosion and varnish off of it. We don't want to take out a whole bunch of this material. Remember, we're going to slide on it. We want it to be snug inside the O-rings, but not too tight. The rust makes it too tight, and if we remove too much material, it becomes too loose and starts to rattle around. So just right is what we're looking for here. And then once it's all cleaned up and these surfaces have been checked and verified that they're still in good shape, we would go ahead and put a little bit of silicone lubricant on that, or brake lube, and put that back into service. Now, you don't want to use any oil-based lubricants on the brakes. Number one, oil is quite flammable. Number two, it reacts with brake rubber. If it reacts with the brake rubber, it can swell the rubber. Some slides have boots on them, and I've seen them come in overblown and they're falling off, and it's because somebody has used an oil-based lubricant on the slides. That is not ideal. So that's our basic caliper cleaning and inspection for you. If the caliper rubs up against the anchor in a sliding type design, of course we would clean where the anchor rides against the caliper and check to make sure that it's tight enough to retain the caliper properly. If the anchor has become excessively corroded, we may have to replace the anchor, which may be part of the knuckle. And if the caliper's been mashed up or heavily corroded or damaged in a sliding system, we have to replace that caliper. So the final thing that we have to look at when we get our vehicle up on the hoist, our calipers are off, our pads are off, we verified that both of those are good. The last thing we want to look at if we've got any type of concern with the vehicle is we want to look at the rotor. Now, this rotor is brand new. This is exactly what we'd like to see. But this isn't always the case. We need a nice flat brake surface. We need a minimum of corrosion at the edges. If you've got a big rust ridge at the top or the bottom of this rotor, that is a prime source of noise. Every time you apply the brakes, it rattles and crunches and all of that good stuff. We don't need that. We don't want that. If we have large corrosion or big deep gouges in the face of the rotor, that is cause for concern. We're going to be looking at replacing the rotor. The other thing we want to look for is heat scoring, signs that the brakes have either been abused or have been locking up or seized on. We want to make sure that that is not the case. So if there's any bluing or heat scoring or anything else like that, you have to find the source. Again, go back to the caliper, make sure the piston moves. Have somebody apply the brakes and try and spin the wheel. If the wheel spins once the brakes are released, the system is operating normally. If you release the brake pedal and the wheel doesn't spin, well, it's staying on. That's a bad thing. So we've looked at our rotor and we've decided that the rotor isn't great. It's got some grooves on it, or maybe it's heavily corroded, or we're just servicing the brakes and we thought, hey, maybe we should service the rotors at the same time. Perhaps when you were on your road test, you felt a vibration. Let's talk about rotor vibration. Rotor vibration is not caused by a warp, believe it or not. A warp can lead to rotor vibration, but it is not the cause of rotor vibration. That brake pulsation that you feel is either a drum out of round, which we're not talking about today, or in the case of a rotor, it is a thickness variation. As the rotor spins, we have an allowable amount of run out on the rotor. Most, it's a couple thousandths of an inch. We would check that run out by having this rotor bolted to the hub and having a dial indicator on the face of the rotor. As we're looking for the run out, we're looking to see if the rotor wobbles at all during its rotation. Ideally, it doesn't. If it does wobble back and forth, well, when it wobbles, it will touch the brake pad on one side in one spot, and as that side moves around, it'll touch on the other side. Every time it touches a brake pad side to side, it will remove a little bit of material from that side. Given enough time with that run out concern, we get high spots and low spots in the rotor. That's our thickness variation. The way that we would check thickness variation is you need a brake micrometer. I happen to have mine right here. A brake micrometer is a little bit different than a normal micrometer. You'll find usually it's got a bit of depth to it. This one looks a little bit shallow, but it works just fine. And it's got a pointed edge, and we're going to put that pointed edge inside of the deepest groove on the rotor face. We're going to have our minimum specification either from the hat of the rotor or from the service information, and we're going to take those measurements and compare them to specification. Now, typically, checking in one spot would be sufficient on most components, but on this, we're going to check in several spots, 3 or 4 to be precise. We're going to check around the radius of the rotor and make sure that they all have the same measurement. So we open up our micrometer, like so, apply it at the same level in 4 different spots on the rotor. So here's our first one, take our measurement, We're going to move that to our next spot. Take our measurement. Third spot. Take our measurement. And so on until we've got 3 to 4 spots on the rotor. We compare those thickness variations against specifications put forward in the manual. It's only going to be 1/1000th or 2/1000ths of an inch of thickness variation before you start to feel that in the brake pedal itself. If that is the case, we're going to take our lowest spot that we measured and compare it to the machine to specification of the rotor. If there is enough material to machine, we can take the rotor over to the brake lathe and have it cut for us, or cut it for us. If there is not enough material left to do a machining operation on the rotor, that rotor is no longer serviceable and needs to be replaced. Let me just dash through my notes here before we sign off, but I think we've covered everything as far as brake maintenance goes. The other thing on the caliper, we want to check for leaks. We want to check the caliper piston on the outside to make sure it's not cracked or it doesn't have large chunks of it missing. Phalonic pistons are very kind of brittle. A lot of people use pliers or vice grips to push the pistons back in. As you saw, I tried earlier with a set of vice grips. In a phalonic piston, that can crack, damage, or take chunks off of them. If you've noticed that there's a piece missing from a phalonic piston, that caliper needs to be replaced or the piston needs to be replaced at a bare minimum. If there's leaks, particularly on a fixed caliper where it's got a seam, that needs to be taken apart and either resealed or replaced. What else have we got? Caliper brackets for wear. We definitely need to check that out. Torn boots and seals. If you have a torn boot or seal, that needs to be replaced. When it comes to pushing pistons back, follow the manufacturer's instructions. If it is a rear caliper with an emergency brake, sometimes those pistons can't simply be pushed back. They have to be threaded back into their homes. So, again, check with the service manual to figure out the operation for resetting the brake system. Never, ever, ever, ever hang a caliper off a flex hose. The flex hoses are designed to transfer brake fluid. They are not designed to hold the weight of a caliper. If you hang a caliper off of a flex hose, you may separate the inside of that flex hose. If it becomes separated on the inside, it becomes a blockage. So you will have a pull when you apply the brakes, and you may have a brake stuck on when you release them because of that collapsed flex hose. So again, if you have a caliper off, suspend it using a hook, a bungee cord, or any other suitable device. Don't let it hang off the flex hose. We've talked about that, taking out the pistons. Bleeder screws we talked about in the last video. Brake anchor service we just talked about now. Measuring, and that's it for this lesson. What I need you to do before I see you again next week, I need you to read chapters 97. Yes, I know you've done it last week. Read it again for the friction material stuff. Chapter 105, which is all about how the disc brakes operate, as well as 106. Follow that up by completing the quiz in East Centennial, and we will talk to you next week all about drum brakes. Until then, enjoy your time. Bye now.